All right, let's jump right in. Today we're tackling a massive challenge in the AI world. How do you build a system that lets you talk to a huge enterprise database in plain English? We're talking about turning normal questions into complex SQL queries, but at a scale that just breaks all the normal rules.
So picture this. Your company has a database with thousands of tables. Not 10, not 100, thousands. And someone needs to ask, hey, who are our top 10 customers last quarter? How in the world do you get a computer to understand that and write the right SQL? You see, the standard way, just feeding the whole database map to a big language model, completely falls apart. It's just way too much information for the model's brain to handle at once. And that gets us to the big technical roadblock, prompt token limits. You know, every LLM has a hard cap on how much info it can look at one go. Trying to cram the entire structure of an enterprise database into a single prompt, it's like trying to fit an entire library into a tweet. It's just not going to happen. And even if you could, it would be painfully slow and incredibly expensive.
So yeah, we're calling this the enterprise scale problem. This is really the first major hurdle we have to get over. How do we give the AI just enough information to be smart without totally overwhelming it? Which leads us to the million-dollar question, right? We can't send everything. So how do we shrink the prompt down? How do we make it small enough to work, but also smart enough to have exactly what the AI needs to answer this specific question?
The solution, it turns out, is to stop thinking about one giant prompt and start thinking about building smaller, way smarter prompts right when we need them. This is our first big architectural move.
So here's the game plan, and it's actually pretty clever. We use a two-model system. When a user asks a question, it first goes to a small, fast, and cheap LLM. Think of it as a bouncer. Its only job is to look at the question and say, okay, to answer that, you'll need the customers table and the orders table, and you can totally ignore the other 2,000 tables. Then, and only then, we build a nice, small prompt with just the info from those selected tables, and we send that to the big, powerful model that's a genius at writing SQL.
And the payoff for this? It's massive. By pre-filtering the tables, we just slash the size of our prompt. This means everything runs faster, and we dramatically cut down on the cost of using that expensive, powerful model. We're only paying to process the information that actually matters.
Okay, so we're getting smarter, but hang on a second. We're still sending every single question to our heavy-hitter SQL model. What if the user just asks something simple like, how many employees work here? Does that really need the same firepower as a super complex question that joins 5 different tables? Probably not.
And that's where this next strategy comes in, using tiered LLM intelligence. We're going to use the right tool for the right job.
I mean, you've got to realize not all questions are created equal, right? You've got your simple lookups on one side, and then you've got these really complex analytical questions that need to weave together data from all over the place. Treating them both the same is just, well, it's inefficient.
So we bring in another little helper, a router model. Think of it like a traffic cop for our queries. After the right tables are picked, this little guy looks at the question and makes a quick call. Is this simple or complex? If it's simple, it gets sent to a smaller, cheaper model. If it's a real brainbuster, then it goes to the high-powered one. That way, our most expensive resources are only used when they're truly needed.
Okay, our system is getting really slick now. It's efficient, it's tiered, but there's still one more optimization we can make. Think about this. What if one user asks, show me top sales in Q1, and another asks, what were our best-selling products in the first quarter? They're basically asking the same thing, right? Do we really need to pay the LLM to figure that out all over again?
And the answer to that problem is our next big efficiency play, something called semantic caching. It's a cache that understands meaning, not just words.
So what on earth is semantic caching? Well, it's not your grandpa's cache, that's for sure. A normal cache looks for an exact text match. A semantic cache is way smarter. It takes every user question and turns it into a string of numbers, an embedding that captures the intent of the question.
And here's where the magic happens. When a new question comes in, we create an embedding for it, and we check our cache to see if there's another embedding that's really, really close. If we find a match, it means someone has already asked basically the same question. So we just grab the SQL we already generated and send it back, completely skipping the LLMs. That saves a ton of time and, you guessed it, a ton of money.
So we've designed this beautiful, efficient, multi-layered architecture. Awesome. But where does it actually live? Where do all these models run? This brings us to a really fundamental decision.
And this is the great deployment dilemma. Do you go with a cloud platform, or do you host everything yourself on local servers? Both have some serious pros and cons.
All right, let's put these two head to head. With cloud platforms like Azure or AWS, you get instant access to the best, most powerful models out there, and you just pay for what you use. It's all managed for you. The catch? Your data has to go to their servers. On the other hand, you can self-host with something like Ollama. This gives you total control. You can use tons of great open source models. Your data never leaves your building, but you're on the hook for buying the hardware and doing all the maintenance yourself.
So at the end of the day, it really boils down to this simple trade-off: convenience versus control. The cloud gives you convenience, scalability, and access to the absolute latest and greatest models. Local servers give you maximum control, rock-solid security for sensitive data, and you don't have to worry about a bill for every single query.
So which one is right for your enterprise? Well, surprise, surprise, there's no magic bullet here. The right answer really depends on your company's specific situation. So to help you navigate this, let's walk through a quick decision framework with the key things you need to think about.
First up, you gotta look at cost. Do you prefer paying as you go with API fees, or are you okay with a big upfront investment in hardware? Next, and this is a big one, security. Does your data absolutely have to stay on-premise? Then you have to think about scalability. Do you need the cloud's ability to scale up instantly, or are your own servers powerful enough? Then be honest about your team's expertise. Do you have the people who can actually manage all this stuff? And finally, what about your model needs? Do you really need the absolute best proprietary model, or could a good open source one get the job done?
Because really, at the end of the day, building one of these systems isn't just about solving a technical problem for today. It's about creating something that's efficient, secure, and can grow with your company. So the last question you should ask yourself is this: are you building an architecture for the data you have now, or for the questions your team is going to be asking a year from now?
And that's our deep dive into architecting NL2SQL solutions for the enterprise. I hope you found this breakdown helpful. If you did, do me a favor and hit that like button, share it with someone who might find it useful, and subscribe for more explainers just like this one. Thanks for tuning in.